this data, but whatever that data is, the population mean will be between 27 and 42. Okay, so again, the idea or the concept of this item is very similar to 7.1. The only thing different is instead of using the Z critical value, we're using the T critical value. Okay, and again, the idea and the procedure and the step is the same. And now they ask you if the confidence level were 95% instead of a 98, would the confidence interval be narrow or wider? So looking at this thing here, just imagine if in order to cover 98%, do you agree that to cover 98% is have to be bigger than cover the 95%, right? Which is in this case, as you can see, this item here is the confidence will be narrow, because if you look at this thing here, the critical value for the T critical value for 95% is 2.031. And if you multiply with a small number, if you instead of everything is the same except instead of multiply to 2.441, you multiply to 2.032, which is if you multiply a smaller number, you will get a smaller result. And if you get a smaller result, you add them or you subtract them, you will get a smaller, narrow interval, right? So again, that's the idea. And again, if you want to cover 98, you have to be bigger than you trying to cover the 95, right? So again, the bigger confidence interval, the bigger percentage will have a wider, the bigger interval. Okay. So looking at this thing here, question with the step, question with the number, or question with the result that we have here. And again, the only reason I mentioned this problem to show you, yes, I can go and just like yesterday, right? Just like yesterday, your calculator does do those wonder for you, right? Your calculator can do all of this shortcut, can calculate all of this for you. The only reason I mentioned this is because on your homework, on your quiz, they might ask you, what is the degree of freedom? Find what is the margin of error. They ask it individually. So that's why I do it individually, so that you can see that to find, your calculator cannot, they don't have a formula for margin error. They don't have a formula for standard error. You have to manually type it in. So again, instead of, your calculator can only calculate the confidence interval, okay? So let's take a look at this thing here. Let's construct the 95% confidence interval with our calculator, okay? So that we can see if the interval is narrow, smaller, or wider than this interval, right?
Mr. Tran?
Yes.
Can you say how you got the T of A score again?
The T alpha over 2?
Right.
Again, the critical value, this is what you do, is you need to have a degree of freedom, which is your degree of freedom is this item right here. This is your degree of freedom right here. Mm-hmm. And again, your degree of freedom is 34. So if you go to 34, if you go down to 34, which is your degree of freedom, which is n minus 1 is 34. So this is my degree of freedom. This is the row that I'm looking for, right? And because they asked me for a 95%, no, 98%, right? Because they asked me for a 98%, which is, again, that is why I have 2.441.
Oh, okay.
You see the degree of freedom, 34, and then 98, right? And again, the part B, I say the degree of freedom is 34 and the 95, that's why we have 2.032. So it's depend on your percentage, right? It's depend on what percent you have, and that's where, you know, depend on your percent and depend on your degree of freedom. You got it?
Yes, so all the percentages at the bottom, that is just the confidence level. And then above that, that's just the Z-scores.
Yes. And everything up here is your T critical value.
Okay.
Yes. Okay. So again, let's take a look at this thing here, which is, again, like I say, the only time later on you have to find a critical value. Like I say, the critical value, they might ask you, you know, the problem is they find a critical value given this information. So you have to look at the table. And when we get to chapter 8, you have to find that table too. we have to use that critical value too. But for now, looking at this thing here, looking at this item, to find a confident interval, your calculator, just like yesterday, can calculate for you. So let's do this thing here for a 95%. So if you have your calculator, this is what you need to do, which is, again, you need to hit stat one more time, right? You need to hit stat, and then after hit stat, you have to go over to test, and then go down to number 8, which is if you pass the Z interval. Yesterday we deal with a Z interval. Today we deal with a T interval, which is everybody see the T interval, which is your option 8, which is if you press in that, which is the same as yesterday, which is we choose the stat. So they ask you, what is your X bar? What is your point estimator? Your point estimator here is 34.85, right? That's your X bar. And then they ask you, what is your standard deviation, which is in this case, my sample standard deviation is 17.9. And then they ask you, how many N do I have? What is your total number of item, which is in this case, my total number of item is 35. And again, the confident interval, like I mentioned, I want to do part B, which is the confident interval is 95, which is 0.95. And then once you have that, all you do is you press enter and they calculate this confident interval for you, which is, again, they have this confident interval. And like I mentioned, you can see right here, this confident interval that we have for 97 is 27 to 42. This confident interval for 95 is 28 to 40, which is from 28 to 40 is smaller than 27 to 42. So that's why the answer for part B is the confident interval is narrow, right? Because it's smaller, right? In terms of that, it's covered less space. It's covered only 95%. The other one is have to cover 98%. That's why the interval is have to be bigger, wider. Okay, so again, looking at this thing here, you know, the same step that you find this item is the same as yesterday. The same step to find or to use your calculator to calculate this thing here, which is one thing, ladies and gentlemen. If you use your calculator, the N is whatever N you have, which is whatever the sample you have. The N is not the degree of freedom. Make sure to know that if you use your calculator, you enter in your N, your actual sample size. If you calculate the critical value, if you're looking for a critical value, then you need a degree of freedom, which is the N minus 1. So distinguish the difference between the two, you know, and again, when you type in your calculator, you do not type in the degree of freedom, you type in the N, which is, look at this thing here, as you can see, the only thing different from yesterday is instead of using the Z interval, today we will use the T interval. Everything else is the same. Okay, let's take a look at the next problem and see how to use our calculator to analyze this thing here. All right, so looking at this thing here, they say, let's go to the movie, the name of the problem. A random sample of 35, same thing as before, 35 Hollywood movie made since the year 2010. Have a mean length of 121.6 minutes with the standard deviation of 20.4. So one thing is, before we begin, ladies and gentlemen, I want to point this thing out, that if they don't tell you, if they don't spell it out for you and say the population standard deviation, or if they don't say a sigma, which is sigma is the population standard deviation, if they write it this way, most likely 99% of the time, if they write it this way, this is a sample standard deviation. Okay, so again, this is the random we have, which is the random 35 item we have. And then with this 35, we have the mean of 121.6 and the standard deviation of just this 35 item, not the population. Okay, so again, if they write it like this, if they write it this way, if they don't spell it out and they say population standard deviation, right? If they say a sample standard deviation, is easy. Sample standard deviation, T critical value. But this is the time that if they write it this way, this standard deviation is a sample standard deviation. With the sample standard deviation, or with the standard deviation which is this item is a sample. That's why we have to deal with a T critical value. Okay, so looking at this thing here, what do we need to use to tell our calculator to calculate for us? Well, we need to have an N. We need to know how many items we have. What is the total item, right? And then in that, we need a point estimator, which is the point estimator in this case is 121.6. And we need a standard deviation, which is the S. In this case, the standard deviation is 20.4. The last thing we need is the 95, which is the level of confidence. Okay, so again, looking at this thing here, if you have the information, if you have this item, everybody see that all we need to do now is tell our best friend, your calculator, to calculate for you, right? So how do we do this? We have just same as yesterday. We hit stat, we go over to test, and then we go down, scroll down to the T confidence interval or T interval, which is option 8. Again, make sure, like I mentioned yesterday and before, the hardest part of this item is to know which one to use, right? How do we know the difference between the Z interval versus the T? Well, if we have a population standard deviation, we use the Z interval. If we have a sample standard deviation, in this case, we use the T confidence interval, which is this. They ask you for X-bar, which is 121.6, and they ask you for a S, which is the standard deviation, which is 20.4, and then they ask you for the N, which is in this case the N is still 35. Make sure the N is 35 and not 34. And again, your confidence interval is 95, which is again, everybody see my information from the problem to input in my calculator. And again, if you type this thing in, your calculator do wonder, which is they give you the confidence interval, which is this confidence interval is 114.59 and 128.61, which is again, that will be your answer. And depend on your connect map, they might ask you for 1 decimal place, which is in this case, we have one that I give you 1 decimal place, which is 114.6 and 128.6, which is again, question here, question with the calculator or question with the answer that we're looking for in part A.
I'm having trouble getting it to come up on my calculator.
If you follow the step, you hit stat.
Yes.
And then.
And where you putting the mean at, when I type it, mine says input with a colon, and then it says data, and it's like blinking. And when I type it, it just goes back like
again,
to the.
You have to choose stat.
Okay.
Go over to stat and press enter so that your stat is blinking, not your data.
Okay.
If your data is blinking, meaning you tell your calculator that you have the data in your L1 or L2, and then you tell your calculator to take those data in your L1 and calculate it. So again, you might have that problem, and we will probably do that problem tomorrow. But again, you have to use stat. Your item have to be a blinking as a stat blinking.
I got it. It looks like yours now.
Okay. Any other question with this calculator, ladies and gentlemen? So, part B, they say that the total of 3 Iron Man movies have been released, and their mean length is 127 minutes. So the mean of the total of the 3 Iron Man movie is 127 minutes. Someone claimed that the mean length of Iron Man movie is actually less than the mean length of all Hollywood movie. Does the confidence interval contradict this? Well, looking at this thing here, does the confidence interval contradict this? Does the Iron Man movie less than all of this item? Not really, right? It does not contradict because the Iron Man movie is actually within the confidence interval, right? Within the ballpark. Our estimate is between 114 to 128. This one here is 127, so it's somewhere in here. So it's not really less than all of the movie, right? And again, as you can see, 127 is very close to 120, 128. So again, it's somewhere there in that ballpark, which is again, unless the average of this number is like 111, right? If it's 111 minutes, then you say, okay, the average of Iron Man movie is less than what we predict or guesstimate. But this thing here is because of our interval contain this number, so we say it does not contradict. It did not contradict that the Iron Man is less than all of the Hollywood movie, because it's in the ballpark we have. Like I say, this one here is a guesstimate. We don't know the actual number is, but we know that it's somewhere between this group, right? So it might be less, it might be more, but we cannot say to be exact because we just guesstimate them. Okay. So again, it's just the idea that we're using this confidence interval to verify if we have contained the individual data, which is part B. Okay. So question with how to use the calculator to construct this item, which is again, the previous problem. The reason why I show you this problem, like I say to you guys on your homework, on your test, they might ask you individually, find the margin of error, right? Or find a critical value. And that's why I give you this problem, so you have an idea that if they ask you for a margin of error, you know how to find a margin of error. If they ask you for a standard error, you know what the standard error is, okay? Or the point estimate and everything along the way. But again, if they just ask you to construct a confidence interval, then again, you just go in and use your calculator to calculate that item, okay? So question here in terms of example 3. Let's take a look at example 4. And again, let's take a look at this thing here, which is, like I mentioned, you don't see anywhere in terms of the population standard deviation. So look at this thing here. They say that the general social survey recently asked 1,972 adults how many years of education they had. The sample mean were 13.37 with the standard deviation. Again, is sound weird, but with the standard deviation, meaning this standard deviation is belong to this mean, which is again, this standard deviation is just sample standard deviation. You have to pick up on that in terms of the problem. When you do the problem, which is tomorrow, you have to pick up on, is it a population standard deviation or is it a sample standard deviation? Because if it's population standard deviation, we have to use the Z. If it's a sample standard deviation, we have to use the T. Okay, so looking at this thing here, everybody see that this thing here, the sample is 13.37 with the standard deviation, meaning the standard deviation, this standard deviation belongs to the sample, which is 3.13. So now they ask you to construct the 98% confidence interval. So what do we need to construct this 98%? Well, we know that we need the X bar, right? We know that we need the X bar, which is 13.37. We know we need the N, which is the total of people, which is 1972. That's the number of adults, not the years, right? And we need to have a sample, which is 3.13. And then we need that confidence level, right? Which is given this thing here, do you agree that we have all the information we needed to construct this thing here? Which is, again, what information I needed? Well, I have everything I needed, which is now all I need to do is hit stat, go over to test. And again, because you have the information, you don't have the individual data. That is why we're choosing stat. We're not choosing data. If you're choosing data, you tell the calculator you have individual data. Okay, you choose that, which is the stats have to be blank. And then again, what is my X bar? My X bar is 13.37. What is my S, which is S is the standard deviation, which is 3.13, and my N, which is 1972. And again, what is your confidence level? Your confidence level is 98, which is, again, everybody see where my information came from, how can you extract those information from your problem, and how to use your calculator to have this information here. And once you have this thing here, you can see that your item, your interval is between 13.206 and 13.534. And again, depend on how many decimal place they want. Most of the time, they probably want 2 decimal place, which is 13.21 and 13.53. Okay, so again, looking at this thing here, question of how to construct this confidence interval. And the B, they ask you the data collected in the early study suggests that the mean in 2000, the mean in the years 2000 was 13.26. A psychologist believe that the mean have not changed. Does the confidence interval contradict this belief? Does it contradict this belief that this number haven't changed? We cannot, right? We have to say it cannot, right? It does not contradict, right? Why it does not contradict? Because this interval 13.21 and 13.53 contain this number 13.26, right? Unless it doesn't contain this number, because again, this is our ballpark, this is our estimate, right? You can argue and say, well, it's changed, right? It does not change, meaning it's exactly the same as 13.26. Well, this is our ballpark. We can have exact 13.26, right? But again, as long as we can contain this number, we say that, again, this interval include this number, so it might not change, okay? In chapter 8, you will see that we do more tests, and we can say that this item change or this item doesn't change, and so on and so forth in chapter 8. But for now, the idea is if your interval include the specific number, then we say that is having, is depend on what the question is. So again, this thing does not contradict the belief, right? The belief thing that it doesn't change, we have no proof that is change, okay? We know that it's in this group, which is contain this item, unless this number is like 12.3, meaning it doesn't contain in this interval, then we say yes, it's changed. Because right now, after we do all this thing here, the number is more than the previous number, and it doesn't include the previous number, then we say, okay, it's something different, okay? So again, looking at this thing here, question with this part A, how to find your critical confidence interval, and part B, how to answer if they give you a specific value. Now, here comes, ladies and gentlemen, one thing is, remember I told you guys that if we have a lot of data, and if we have a lot of data, remember this thing right here, right? 13.206 and 13.534, right? If we have a lot of data, which is in this case, we have a lot of data, right? Our data is 1972, which is, remember last time, they tell you that if your N is bigger than 200, what are we using? If your N is bigger than 200, we actually using the Z, right? Because if it's, so if you were to make a mistake, and here comes a small item is, if you were to make a mistake and you use a Z, if you were to make a mistake and you use the Z interval rather than the T interval. So one thing about this thing here is, even if you use a Z interval, which is, again, your mean is 3.13, your X bar is 13.37, and your N is 1972, and the confidence interval is 98, which is everything we have. If you actually using the Z for this problem, the result is the same. The result, as you can see, I told you, remember 13.206 and 13.534, which is, again, the reason being is, like I mentioned, is the bigger the n, the bigger the n value, the bigger the n value, the t distribution turn out to become a standard normal distribution, which is the z item, right? So looking at this thing here, anything bigger than 100, is, if you accidentally using the z instead of the t, does not have that big of a change. Okay, the only problem is if your n is like 40 or your n is like 10. If your n smaller, if you have a smaller data, if you have a smaller total, and the answer will change tremendously because the t value will always be bigger than the z. So that's why if, let's see, is this a calculator? So again, if you look at this thing here, if you look at this thing here, if you look at this number that I have here, as you can see, the bigger the n, looking at this item here, the number is very close, right? For a 95%, the z is 1.96, and this number, as you can see, the bigger the data, the smaller the t value, which is, again, that's why when we do the 1972, the number is big. That's why the t value is very close to the z value, and that's why the answer come out to be the same with your calculator, because it's very small that it doesn't detect the difference between the two. Okay, so again, as the data, like I mentioned, as the n get bigger and bigger, as the more data that you gather, then your data will eventually become a normally distributed, become a normal standard. And that's why I try to, I give you that last problem to show you that when the n is big, right, the n in this case, the n is equal to 1972. If the n is big, it doesn't matter if you use a t or a z, the answer will come out to be the same. Okay, but the problem is, most of the problem that they want you to use the t, the n will be smaller than 200. The n will be 20, and if you use the z, the answer will be tremendously different than the t. Okay, so first of all, question with the 7.2, this is the n of 7.2, which is, we still try to construct the confidence interval. The only problem is we don't have a population standard deviation.
Just a quick question. So for population, you said we use the
z,
and then
yes.
The sample is the t.
Yes. Any other questions?